I think the sound doesn't work, but I can hear myself. So my sound works, yours doesn't.
Yeah, test, test. Oh yeah, okay, it should work now. All right, we have audio working, I'm pretty sure. So I'm just gonna briefly repeat the things I said before.
It works now.
All right, so we have a holiday break. Well, you could have seen it here as well. Holiday break, next 2 weeks, no Nix Hour, new one in January. We have a new schedule, so we pick a new time every month, and we'll keep that same time throughout the month and change it again in the next month. And then the next Nix Hour will be on 3 p.m. on Fridays. And yeah, hopefully that will allow more people to join when they have time. Okay, that out of the way and the sound working now. Let's go to this week's issue, which is debugging Nix code. So, by the way, if you want to suggest a topic, you can open an issue in this repository. But so yeah, today, let's briefly read. So, struggle to debug Nix code. Very cryptic kind of errors, and it's difficult to use some like built-in functions. There's trace verbose. How would you debug Nix code? And so this is something else. This is more about debugging derivations. Yeah. So I think one interesting thing we could try today was to look at a Nix package's failure. So offborg, the CI for Nix packages, evaluates like all the packages for every PR, which is also why it's really slow. And I thought, let's look at a failure without looking at the fix. And so to find a failure, I first had to find a fix, but now I'm gonna really try to not actually look at what the code does and see if we can find the failure ourselves. It might be interesting, might not be interesting, but let's give it a try. So this is the PR. So I think how I can do that is go to a Nix packages clone. I'm gonna check out this PR. Hope it's still available via the GitHub CLI actually. Yeah, that seems to work. So I'm just gonna git, I guess, git checkout of head like this. Okay, we should be in the Nix packages state. That fails, and specifically nim should fail. Let's try this. I'm just going to use Nix instantiate. I don't need to build nim, so this should be fine, and it works. Was there something else here? Maybe, okay, let's look at the CI failure maybe. Scrolling down here to not mess it up. We have a CI failure in this PR, so this should actually fix it. So I'm not sure why this still fails. Oh, nimble. It's not nim, it's nimble. Nimble unwrapped. Okay, well, I guess this is a fairly simple failure. I do know of another failure actually on master that just happened like a couple days ago. We might try that as well. So, well, attribute nimble unwrapped missing in this case in all packages.nix. So, I mean, this is a simple fix. I'm just going to go into all packages.nix, nimble unwrapped. And, well, right, I mean, one way to fix failures is to grep for things. That's one of the probably most useful skills if you use Nix. So nimble unwrapped, and so it says attribute is missing, and so here, well, I guess my immediate thought is that this file doesn't export nimble unwrapped. We could go into here and check the default.nix if it is there, or I mean, we could also evaluate this ourselves. Well, actually, no, we can't directly. So yeah, let's go into the file, default.nix, nimble unwrapped, and yeah, we can. I searched for it, but there's nothing, no result. Oh yeah, it's called nim unwrapped. So okay, there's that. Oh yeah, and here at the end it seems to export just nim and nim2 build packages on nim unwrapped. Okay, so maybe it was renamed to nim from nimble. That might be the case. So this would probably be. Actually, no, it's. Oh, okay. We have nim unwrapped, we have nim unwrapped 2, and nimble unwrapped. Okay, so probably I'm gonna guess the fix was maybe just to remove that. Though I guess we should also check the history. And for that, I'm just gonna do this and grep for nimble. Yeah. So we have a commit here, remove nimble from nim wrapper. Okay, so it was removed, but apparently this commit here didn't remove the mention in all packages.nix. And that's fairly easy to miss because, right, we saw before, if we do nix instantiate of just nim, it didn't fail. Oh, we actually get a new failure here. Okay, let's debug this too. So this is actually a very common error. If you used the call package pattern, you will likely have seen this before. It's a bad error message. It should be improved. So, well, in this case, I mean, let's look at the error a bit more closely. Anonymous lambda called without required argument nimble unwrapped. So apparently this function was called, but so these are the function arguments, and there is a nim. Well, there's a nim unwrapped. Can we also see the nimble unwrapped? Yeah, here. Nimble unwrapped is also here, but it wasn't passed. And so if we wanted to kind of more properly try to debug this, it would be figuring out how this file was called. And it would be a fairly deep rabbit hole. But I guess the basics of it are grepping for this file. Another grep compilers nim. And that would give us this, and that's exactly what we edited just before. Compilers nim. Compilers nim. Okay, so it's called here, and then we get to we figure out that, oh, it's using call package. It's not doing like an import of the file directly. And so then we could dig into the call package pattern, and that should be familiar to a lot of users, but let's briefly go over it. And I wonder what the best reference docs for that is. Let's see, is it documented in the Nix packages manual? Call package. There's call package with, which is used by call package underneath, but it's not exactly the same. Actually, yeah, we can see here, this is how it's usually defined. Yeah, so we can kind of get a notion of what it does here. So call the package function with the required arguments automatically. The function is called with arguments args, but any missing arguments are obtained from auto args. So now we can see that, well, auto args, oh, here, auto args is the first argument. In this case, it's packages, and that's also what Nix packages uses. And so, yeah, any attributes are filled in from packages. So then we could figure out that, let's try Nix instantiate nimble unwrapped. We'll see that the attribute doesn't exist, and so then we could notice that it can be removed. There is some code that tries to be kind of smart about it. So if we had, let's say, typo, let's say num, Actually, num also exists. Numble. No more. Yes. And we tried this. Yeah, call without requirement. No more. Kind of hoping to trigger the automation to figure out the argument automatically. Does not work. Actually, let's just make 100% sure. What if you have make wrapper 2? This I don't think should exist. Yeah, okay, that seems to be broken here. Interesting. Is this like, no, this shouldn't be super old PR. Okay, well, let's maybe skip over that and just go onto master and master detach. So I think I showed this off a couple times before already, but let's say we evaluate nim. Let's go into the nim expression. And now let's try this, make wrapper 2. Try this. Doesn't work.
I think it was for attribute access, not for arguments.
There's a separate thing that should make it work for call package as well. And well, I implemented that, but apparently it's broken here. So yeah, I'm not sure what's wrong in this case. Oh, it could be, I think I might know the problem. So let's go back to here, compilers, nim, nim, compilers. Oh, was it? Oh no, it's here, it's still here. Oh yeah, okay. The problem is that it's called with call packages, which is almost the same as call package, but it's not for a single package, it's for multiple. Let's see, is this documented call packages? Yeah, it's documented similarly like this. I do wonder if call package doesn't have a better section though. Maybe not. Yeah, maybe not. So, although I do know there is some documentation being written right now, but okay, let's continue a bit. Yeah, and so actually I could demonstrate this with something that's not call packages. So in here, so a common typo is fetch from GitHub, lowercase h. This doesn't work. And if I try to evaluate this, actually, what did I change? Muon lang. Here. Oh. Okay, we're running into all sorts of different errors that I'm expecting. In this case, there is a special case for exactly this, which could actually be removed. So there is one right here, fetch from GitHub with lowercase. Yeah, so this could actually be removed, and then it would give the error that I do expect, and that is something like this, right? Function called without required argument, fetch from GitHub. Did you mean fetch from GitHub or fetch from GitLab? So there's some string distance matching going on there. All right, so maybe let's do something else. Let's check out master again, or reset to master. And let's see git log. I think there was a fix very recently. Fix GC service, fix Darwin build, fixes mount. I think it was something with CUDA actually. Prefix lib, fixing missing new line. Correct hash. Yeah, I am not. Oh, to print evaluation of Godot. Okay, maybe let's check out this one. And I guess I should actually take a look at the commit. So go into Nix packages. Actually, we have kind of the fix right here. Hopefully amends this. Yeah, this is actually kind of pretty tricky. How to find something that doesn't evaluate without... Okay, yeah, this is the one that I was thinking of. So I guess historically, this is the peer that broke it, or I think so. Although the checks didn't finish, and that's partly why it was broken, because we didn't wait for that. But so we don't actually have the error in this peer for what broke. But if we are lucky, we can find some PR from a couple days ago. Yeah, this is not great for finding something that breaks. Maybe here, I see a red cross here. Yeah, okay. This should give us an evaluation error. No, it's a build error. Yeah, so maybe we need to write some of our own code. Or maybe we could go to this course and search for some evaluation failure. What would this be? Error? Well, that's not going to be very helpful. Error. Cannot write. Syntax error, unexpected. So syntax errors aren't very interesting. Output missing. Yeah, I'm not sure. Yeah, not a lot of these are actually evaluation debugging. So, okay, maybe let's change things up a bit. Let's write our own code. I think this hasn't really worked out that well. So this is a Nix Hour number 55. I'm just going to go in here. Maybe let's start off with, let's see, what if you write some interesting code that, now, is the entering, maybe we could use Rosetta code to just code some random algorithm in Nix. Or actually, advent of code would also be an option. Acromant function, 24 game, 100 doors. I don't know many of these, but there's a lot of examples here. So we're resolving programming puzzles on here now. So 100 doors, you make 100 passes. The first time visit every door and toggle the door. Second time only visit every second door and toggle it. Okay, we can do that. Yeah, okay, that's kind of interesting. So we have 100 doors. How do we do this? Let's say we have, let's do it simply. Let's say, well, we need lib. Let's import that very cheaply, very impurely, like this. And so we're gonna say, let's use rec here, because I don't want to always have to declare what I output and have some intermediate variables. So we're gonna say initial state is the 100 doors. Now we need a git gen list for this. So I'm going to say initially they're all closed, so we're going to use false for this. 100 of them, and let's make this variable. Let's say count equals 100. All right, and now we want to make passes through here. Let's say first pass, and then we toggle every second one. So we can do this using lib.imap. Well, I'm kind of worried that well, let's hope I make a mistake here somewhere. So the state, and then we check if so we use lib.mod, if mod2 is equals to 0, then flip it, and we could do, well, the let's do it simply. Let's say if then not state, else state. Okay, so we flip every second one. Okay, hopefully I made some index mistake here. So IMAP, we map over the initial state, and let's just check if that does what we expect. And also let's keep it only at 10 doors. All right, Nix Hour 55. And let's evaluate the initial state. We need to make it a bit bigger and add strict. Okay, all of them are false. Strict-A, and now the first pass. Okay, we have false, true. So this is only every second. Door number 2, is this right? That is right. Okay, no failure so far. So then we just need to kind of abstract over this. Let's say...
Oh, it's second pass then.
Oh, oh yeah. Oh, yeah, you're right. So first pass, that's, I guess, mod 1. So let's say pass, and then the like K for the pass that we have. All right, and then we just switch out the mod for K in here. Okay. And then until you visit the after the last pass. So how many passes do we need? I guess until K is 100. So let's just say result, and then we need to map over there and say, so fold L takes an accumulator, an element, and then returns an accumulator. We need the initial state, which is here, and we need the list. And the list, we're gonna just generate the list just like we did before. So in this case, I think like this. And yeah, we might not need 100. Probably 99 is enough, but actually count. Let's use count. But it should be fine. Okay. Accumulator element, accumulator. Let me format this a bit better. So we want to make a pass, and the pass will be, so this is K. So we say K, and we don't want the initial state, so let's just remove this. We can use some eta transformation. So it's the same as state like this. But we can remove this because it's equivalent. And so we just need to make a pass with the state right here. Okay. And let's try this. Result. Oh, division by 0. Well, we have an error. It's kind of obvious where is it? Well, yeah, I'm not sure. Okay, we have an error. That's good. So something I wanted to try is the debugger, which we tried before. It didn't work that well there. But let's give it another try. Actually, I think that's only in the new REPL or Nix eval. No, that's result. Okay, division by 0. Let's just see what we can do here. Yes, you can see I'm not actually used to using the debugger. But so we have backtrace. Actually, that is kind of useful because if you use the, well, you'd have to use -- trace to get the backtrace otherwise. Okay, while calling, although this is inverted, isn't it? Yeah, it sure is. So okay, in this case, we can see, yeah, this is actually terrible. It's exactly the opposite order from what you get with show trace. Okay, so I want to kind of inspect the last item here. Can we also just print the very last or the last couple back traces? Change it to another trace in the stack. Go on step env. I don't think we can. But let's see env here. And yeah, the env level 0 here, I guess, is the one where the error occurred. So we have an integer available and base available. So if we scroll up here to where the error occurred, we have base and we have int available. So yeah, we can see here this is the most inner environment. So an environment in this case is just a scope with variables. And this is the outer one. So we should have access to both of these variables in here. Let's just check this base and int. Okay, I mean that then should help us a lot. In particular, we can see division base by int. If we try this ourselves, it's going to give 0. Actually, did it enter us into a nested REPL now? Yeah, it did. Okay. So, well, we figured out the problem in this case. We made use of the debugger to some degree. I wonder if there's anything else that's kind of useful here. Env level 2, that would be, let's see, can we see this here? Not really, so that's the other variables available in this file. It doesn't show the file here, which is not great. So other functions available in the file. We have lib, I think that's as well in the file. And these are the built-ins. Okay, so nothing too special here actually. Maybe before we jump out of the debugger, st, we did that already. St changed to another trace in the stack. So can we, yeah, actually, let's see. So if we say backtrace, so here we have numbers, okay. And so in this case, we have access to the base and int from this scope, but we don't have access to the state here. So let's try to jump to this scope here, number 2, and then print state. So that should be st2. Okay, state is available. And we can print this, it is false. So, and we can also get access to I. So we can see this is the, well, second door, or the door at index 1. K is 0. Yeah. Okay, so it comes from here. We also have count initial state, yeah. Okay, so first time I'm using these features. The debugger could be improved a bunch, but that is interesting. What happens if we continue? Okay, it just fails. How can we, oh, right, built-ins.break also exists. So I guess that's only useful when we do that explicitly. Yeah, so the debugger wasn't added. I think it was already added like 1 or 2 years ago. But unfortunately, there's almost no docs for it. So there is only like one article by the author, I believe, that kind of talks a bit about it. And yeah, there's no reference docs in the official manual, so that's a to-do item. Yeah, well, if someone wants to do that, please go ahead. Also doing these small improvements to the debugger would be very helpful. I heard it had problems with like larger issues though, or like when you have a failure and there's some try eval, although try eval shouldn't be a problem. Anyways, so okay, we identified the problem. Let's try to fix it. In this case, I see the problem. Gen list, well, I mean, I guess it's not like super obvious just yet. Well, or we can backtrace this in that k was 0. So gen list must have generated one that was 0. And the list elements are just well, they come from the function here. And so we can kind of see that, well, actually let's try this a bit more. So in this case, we don't have access to this variable itself, but we kind of want to see what it is. So let's make use of, let's try.
You can access this in fold function.
Well, the fold function only gives us access to the k
I mean,
here.
it is an argument to the fold L, so if you check fold L function.
Oh, you mean in the evaluation?
In debug area.
Yeah, let's try this. So like this, so backtrace, are we in the fold function here somewhere? Well, we should be. Pass, we have an IMAP, we have pass, IMAP, pass. Oh, actually, no, it should be somewhere. IMAP, pass, IMAP. Why is there so many passes and IMAPs here? I don't see any. Oh, is it because fold? Oh, I think it's because fold is a built-in function, so that doesn't work.
Maybe it's somewhere at the bottom.
We are already at the bottom here.
Oh.
Yeah.
Yeah.
So, kind of a hacky workaround would be to use fold L without the prime. This is a function implemented in pure Nix code. It's less efficient. I don't really recommend using it, but it would just allow us to demonstrate that this was actually the problem. And if we go, is there a fold here? I don't see a fold still. Well, okay, let's not do that. But yeah, let's try printing this variable in between here. And so there's a bunch of functions in this library. So there's this Nix packages unstable, stable. There's a library for debugging Nix code. It's a bit hard to use, but it has a lot of functions. Let's try giving it a go. So it is right here, lib.debug. So we can see we have trace-like functions, take two values, print the first to std and return the second. And we have trace val-like functions, which take one argument, which is both printed and returned. So in this case, I think we want the trace val1. So we can do lib.debug.trace val. And now this would probably not work. So let's give it a try. Result. Yeah, so we can see here it traces the, well, actually we don't get the error at all. Well, now we can't really see it, so let's actually do this. So it just prints primop, and that is because it prints this argument and returns it. So it's actually kind of like this. So what we really want is the parentheses right here. Okay, let's do that. And well, now we run into one problem with lib.debug. And because this has annoyed me for so long, actually there's a PR that fixes this. Hold on, we might be able to just use that. That would be trace deep sec, something like this. Yeah, here, this one. Yeah, I should actually review this. This is really nice. Okay, so we're gonna check out that PR. Hopefully I can upstream this until next week. or finish the review until then. So instead of importing lib from here, I'm going to import it from my local checkout that I have. And the impurity is actually beneficial in this case. Okay, let's try this again. It's still the same. Hold on. Oh, it's a separate problem. Yeah, okay. We should read the documentation, really. So we have lib.debug. We have traceif, traceval. Okay, trace a supplied value and return it. It doesn't say that it's lazy, but it is lazy. So instead, we want tracesec or tracesecval. In this case, it gets deepsect first. We have tracesec n, tracevalsec fn. Here, this one. So tracesec means it will evaluate it beforehand, and well, it will evaluate it deeply. So like you won't have any thanks printed. And val means it takes the first argument and returns it as well. So we do this and we actually get some output now. All right, very nice. So we were able to print the result of this function call, but maybe we can also make use of this fn thing here. Let's see if that is somewhat described up here. Yeah. Functions that end in fn take an additional function as their first argument, which is applied to the traced value before it is printed. Okay, do we have an example? This. So you have a function, a value, traceval, so it returns the value, but it prints the thing applied on the function. Is that actually useful? Well, in this case, I guess let's say we add a function in the front here and say lib.length. So just to confirm the length of the list, and that seems to work. All right. Now, oh yeah, something that I can very much recommend is using traceval. So we're not going to use val now, but we do use the sec variant, and so now we need the first argument to be the thing we want printed, in this case empty. But the thing I can recommend is just to make that an attribute set and put the things you want to know in here. So in this case, inherit initial state, for example. Actually, I guess it doesn't really matter that it's here right now. It might make more sense in front. Actually, let's put it inside of here. Yeah, right here. So gen list, I'm gonna debug tracesec in here and then return the thing after it. And this actually should work. Well, let's print k. Yeah, okay, that works. Now if we add strict, well, we get a really long trace. I'm actually going to move stuff around a bit here. Okay, so we get all the output and then the division by 0. So this is actually kind of confusing because 0 was up here. Why did it progress this much? I think that comes from, yeah, that comes from laziness. So it can actually loop through the entire thing. Wait, hold on. This shouldn't, because we have a fold L strict here. The strict variant should evaluate this at least weekly. Oh, yeah, that's a problem. So let's demonstrate this. So let's go in here. Let's have a built-ins.fold L like this. And have an accumulator, an element, just pass this through. Let's say we have, sure, null. And then 1, 2, 3. Okay, so nothing much happens. If we add, or let's say, what if we have an evaluation error in here? So let's say throw element. Okay, actually, toString element. All right, so we get an error. The error is 1. That doesn't work. But if we put this, well, actually, this doesn't work on the first element. All right, but if we put this into a list like this, this is terrible for demonstration because Nix REPL does a strict evaluation on its results. So instead,
it doesn't, does it?
It does. So if we do this, throw foo, it evaluates it deeply.
It just doesn't show. If you have a trunk there, then it will show a trunk, right?
Also, yeah, that's kind of the problem because if we just evaluate, so let's say we assign this value instead. Let's just say x equals this value. Actually, let's do it like this. X equals this value, and now we just do a like, let's say, built-in.length of this list. Yeah, that demonstrates it. So yeah, so we can evaluate the length of the list. We can evaluate x itself, but we just can't access the element without an evaluation error. So element 0, then we get the error. Kind of the Nix REPL kind of makes this a bit muddier in that it evaluates top level values deeply by default, and there's no way to turn it off. Well, actually, there is -p, which should only do that actually. Well, so it's a bit confusing.
If you use attribute set instead of list inside, it will be lazy.
Well, list should also be lazy. Oh. Yeah, this does the same thing.
Maybe function call.
But so what I want to say is that it only evaluates it on like one level, on the kind of, so in the Haskell you'd call that weak head normal form. It only evaluates the well, for integers it's the integer itself. For attribute sets it's only the attribute names. So if you have like foo equals 10, that works. Well, actually, we need to do the kind of thing. We can use built-in.sec to kind of simulate this. So built-in.sec only evaluates the weak head normal form, the spine of the argument here. So this works, but this doesn't. And the same for lists. So if you have a throw inside of a list and just evaluate it not deeply, it doesn't throw. There is deepsec, which does evaluate deeply. So deepsec goes into the entire structure. And in this case, this might be what we want. So if we go back to the fold L, so we generate some list in here somehow. And now we could say built-ins.deepsec, although then we need to repeat the argument, which is not really the point. This is a bit messy. But okay, so going back to here, so we have these passes, and the pass returns a list, and so that's why the error only occurred like after all of these traces have been printed.
But doesn't it return the function call instead of the list itself?
Oh, yeah. That's another thing I wanted to mention. So in this case, this is the same as this, because the trace sec, so if you have it like this, the first argument gets printed, the second one gets returned. And so this is just the same as pass itself. well, or in the end. But for clarity, I guess this might be nicer. And maybe, does it fix it? No, it doesn't fix this problem. But so if you wanted to evaluate it more deeply, we could do something like this in here and say result equals pass, and then trace sec like this, and then actually built-in deep sec of pass.
Result?
Oh yeah, result. So yeah, now we actually get the trace and the error together. This is a bit, you usually won't have to worry about this, but this is, I guess, good to know. Alternatively, I think we could also adjust the pass function. So currently we can do pass of, like, let's say pass example equals pass of 0 on, I don't know, some list. That's true. So this shouldn't work. Pass example. But so like we can still evaluate it. We can still get lib.length of this. And maybe we don't want this. So what if we say we want the pass function to actually error eagerly when something like this occurs? And we could move the deep sec into here. We could say result is this, then say built-in deep sec result. So this way, if we evaluate pass example here now, wait, that still, oh. Okay, yeah, we have a something I don't immediately know right now. So we apply pass, we have a 0, and we have the deep sec in here. Oh, yeah, okay, I see. Well, I see the problem, although it's kind of hard to know it. Maybe let's use the debugger here. Oh, yeah, actually, that's a great example. So I'm not sure why this happens. I want to print the variables. Let's add a built-in break, which I think works like this. So we can just kind of break and do it like this. Yeah. All right, so we are at this location. We should have the variables in scope. And now let's see what the result is. And what? Result trace, it re-entered us. Is this, oh.
It's the wrong result.
Is it? It's the wrong result. Why is it the wrong result? Let's, why does it fail now? Yeah, so backtrace, wait, what? Hold on, pass example. Oh, attempt to call the function, not a function but a thunk. Oh, this is terrible. Oh no. Hold on. So, is it right that build-in.break that kind of doesn't work? How does that work?
You can check colon.doc in front.
I'm not sure it's documented. It is break on a value, return the argument v. Yeah, that should theoretically work. So this seems like another, wait, hold on. If I remove break, does it work? It does give us the error that we expect. Yeah, this is weird. And maybe let's also do some Nix REPL stuff. What is pass? Okay, pass is indeed a lambda. Well, yeah, pass example. Yeah. Okay. Maybe let's think. Well, I know the problem. So, built-in
By the way,
stuff.
why is pass highlighted differently in your editor? Maybe it's some keyword or something?
No, it shouldn't be a keyword. I think that's just weird highlighting. Or I'm using tree sitter. And I think it. I guess might come from pass through. Oh no, pass. Whatever. So, well, I kind of really just want to say, in this case, the problem is that we need to get the list as another argument. So, result is actually a function, and I guess we should have just used lib.debug.trace result. That should work. Debug.trace. There's no trace. This is a bit weird. Trace sec. And it doesn't. Oh, now we added it. Right. So yeah, trace sec. It's a lambda. So we just deep sect a lambda, and that doesn't do anything. So let's go back here. Okay, we deep sec the result. Now we get pass example and we get the error immediately. Well, we can't even compute the length of it anymore. Like this, yeah. So we made this a bit stricter. Okay, let's leave this in. And now we can also get rid of this. And let's try evaluating the result again. Okay, now we get the error immediately here. And yeah. And so briefly going back to the trace sec here, it's really useful in here because you can just add more variables in here. You can say, let me also print state. And now we get the state here. And now I think this should be changed, and actually that's what the PR should fix. If you use tracesec n, you can give it a number to say how deeply it should recurse. By default, the tracesec recurses infinitely deep, or at least to some degree. But also the good thing, well, at least in this case, is that it prints it in multi-line format. And so, yeah, we can just like, if you have anything complicated here, you can just add it in here and say like, yeah, it will print it. Okay, we are like almost out of time, so I think let's actually try to fix the problem finally. And I can leave this in, I think. So, on the problem, well, we kind of realized that the gen list, and actually this is kind of what I wanted to do, to say the generated list is this here. And then generated list here. Now we can actually print it. So now we could say lib.debug.trace_sec. So sec, we want to print it and then returns the second thing. Generated list. Yeah, so we can see it ranges from 0 to 9. We want it to range from 1 to 9, I think. Yeah, we want to make step sizes starting with 0, with 1. So I think we can just remove 1 from the count and add 1 here. Now if we do that, oh yeah, we get a lot more output. We can see here this is that. And maybe let me comment this out here. Just get this. Okay, so this is the final state of the 10 doors. I guess let's complete the assignment. 100 doors, and now it's a bit hard to read this, so let's say pretty, or let's say result indices. Say this is a result, and let's do an IMAP I, L, and then well, we kind of need an iFilter. There is an iFilter function that I have peer open myself actually. So we're gonna IMAP first, I think, for now. We're gonna say inherit IL over the result.
But you can just leave nulls where L is false and I where L is true, and then you can filter out nulls with
that also works, yeah.
Flatten function or something like that.
Yeah, that works in this case, yeah. If element, so if it is true, we want to keep it. So then we just print the I,
yeah.
Right? That is null. And then we filter out the nulls. So L, let's use the is null. There's also, I mean, this function is, there's some people saying it's deprecated, but it's not deprecated. It's perfectly fine. And some parentheses. Actually, let's see what happens if we don't add these. Yeah, values of function. Well, a list was expected. Well, maybe the debugger would work here, but let's finish this for now. So add the parentheses and try this. And we have a very nice result. It's apparently the square numbers. All right.
We need pipes.
Yeah, so actually I just wanted to mention as well, there's pipe, which we can use in this case. And it would look like this. So you're just going to flip it around. You pipe this value through the functions in the list. So we can do this and get the same result. I'm going to comment this out so we just have the nice result. And just for the fun of it, let's do this. And oh yeah, this might be.
And come back at next session in January.
Yep. Yeah, so this is an annoying bug in Nix. We ran into like 5 bugs today, where you can't cancel Ctrl-C anymore, so you need to kind of kill it. So let's be not as big with the number. Okay, yeah, it's already took like 200 milliseconds. Yeah, so I think that's a good time to end it. We've seen some things struggled a bit, but hopefully that helped. And so yeah, summer, well, winter break. Next Nix Hour is in 3 weeks on Friday, 3 p.m. And yeah, have a nice Christmas, nice New Year, and see you then.